Hello, GCC students for Chem 130. Welcome back. We are in chapter 10. We just learned about mole ratios. Now we're going to combine that with molar mass calculations to do something new. So these are pretty fun. We are going to learn how to go from the mass of a compound to the mass of just one of the elements in that compound. To do that, it's going to be a 3 steps. Let's look up here at our steps. We start with grams of a compound. The compound could be water, ammonia, CH4, salt, aluminum oxide, just some sort of compound, and we give you grams. We're going to use the molar mass of that compound to change to moles. We've already done this. We know how to do this. So then we're going to have our moles of the compound. Then we're going to learn what we just learned in the previous video, which is the mole ratio, to go from the moles of the compound to the moles of the element in question that we're asking about. Except we're not asking for moles this time, we're asking for grams. So we're going to use the molar mass of the element to go to grams of the element. So we're just adding on to that mole ratio step we learned in the last video by putting molar mass on either side of it. So we're going from grams to moles to moles to grams. Okay. Why are we doing it this way? Well, you can't go into a laboratory and measure out moles, can you? The balances are not for moles. The balances measure grams in a science laboratory, not pounds, but grams. So we typically will start with grams and we'll want to end with grams because that's what the balance can measure out in a laboratory. All right, let's look at our first question. Number 1, calculate the grams of carbon present in 75.0 grams of C3H8. Start with what you're given, 75.0 grams of C3H8. Now we need the molar mass, so grab your calculator and grab your periodic table for us to do this calculation. We need to figure out the molar mass of C3H8. So that's going to be carbon, which is 12.01 times 3 plus 8 hydrogens at 1.01 each is 8.08, gives us 44.11 grams per mole. Now, do we want grams on top or bottom? We started with grams, so we want grams on the bottom. Yes, the bottom. 44.11 grams on the bottom and 1 mole on top. That gets us to our moles. Now we're going to do that mole ratio. How many carbons are in C3H8? Well, you're correct if you said 3. There are 3 carbons, 3 moles of carbon in 1 mole of C3H8. So that's our mole ratio. So C3H8 will cancel out and we'll have carbon now, moles of carbon. But we don't want moles of carbon, we want grams of carbon. So we need the molar mass of carbon. Go to your table, find carbon. There it is. Carbon is 12.01 grams per mole. Now, which is on top, the grams or the moles? Well, this time the grams are on top, right? So grams are on top because we're finding grams, and the moles will cancel out of carbon, and we're going to find grams and put it into our calculator. All right, here's what the whole thing looks like written out. There you go. We've got 75.0 grams C3H8 times 1 mole of C3H8 over 44.11 grams C3H8. Again, that is the number from adding up 3 carbons and 8 hydrogens from the periodic table. That's the molar mass. Molar mass goes between grams and moles, always. That's how you go between grams and moles is molar mass. Grams of C3H8 cancel out. Second step, 3 moles of carbon over 1 mole C3H8, mole ratio step. The moles of C3H8 cancel out. Last step, third step, 12.01 grams of carbon over 1 mole of carbon. Moles of carbon cancel out. Molar mass, by the way, is always one of them. You add up 1 mole of them. Okay, so a molar mass, you just add up one of them. 1 carbon is 12.01 grams for 1 mole of carbon. Again, moles of carbon cancel out. We're left with grams. And if you punch that into your calculator, you get 61.3 grams of carbon. All right, good job. So we went from grams to moles to moles to grams, from the compound to the element. Let's try another one. Number 2, how many grams of chlorine are in 51.25 grams of SCl6? How would you name that? You should know your names. Sulfur, what is 6? The prefix for 6? Hexachloride. Good job. Sulfur hexachloride. I could have said sulfur hexachloride. I didn't have to say SCl6. I could have said sulfur hexachloride in this problem. You've got to know your names. Anyway, hit pause and solve this question real quick. You're going to go from grams to moles to moles to grams. Good luck. You can do this. Hit pause. Welcome back. We are solving for grams of chlorine given grams of SCl6. Let's put the answer up. Hopefully you got this correct. We have 51.25 grams of SCl6 given. We need the molar mass of SCl6. So that would be chlorine, which is 35.45 times 6, plus a sulfur, which is 32.07, equals 244.77 grams. Grams is on the bottom to cancel out. That is 1 mole of SCl6 on top. Molar mass. Remember, molar mass is always one of them. You add up one of them. SCl6. Grams cancel. We got moles. Second step, mole ratio. How many CLs are in SCl6? 6. Yeah, you got 6 moles of chlorine over 1 mole of SCl6. Moles of SCl6 cancel out. So we have moles of chlorine, but we need grams. So the molar mass of chlorine is 35.45. That's for 1 mole of chlorine. So 35.45 grams of chlorine over 1 mole of chlorine. Moles of chlorine cancel out. We get our grams of chlorine. You punch that in your calculator and you get 44.54 grams. Good job. Now, someone may ask, in that last step, when we're doing the molar mass of chlorine, why is it just 1 Cl and not 2? Because chlorine's diatomic. Well, the chemical is SCl6. So chlorine is not alone here, so it's not diatomic. So we don't add up Cl2. We do not have Cl2, we have SCl6. Okay, so we are just adding up the mass for 1 Cl for the last step. Okay, so you got your 44.54 grams. Sig figs. We started with 4. The molar masses have 5 and 4, so we end with 4, right? Pay attention to your seg figs, of course. All right, that's it for this step. See you in the next video. Bye-bye, GCC.